Suppose you work for a foundation whose mission is to support researchers in mathematics education, and your role is to evaluate grant proposals and decide which ones to fund. You receive a proposal to evaluate a new method of teaching high school algebra. The research plan is to compare the achievement of students taught by the new method to the achievement of students taught by the traditional method. The proposal contains good theoretical arguments why the new method should be superior, and the proposed methodology is sound. In addition to these positive elements, there is one important question still to be answered. Does the experiment have a high probability of providing convincing evidence that the new method is better than the standard method, if in fact the new method is actually better? It is possible, for example, that the proposed sample size is so small that even a fairly large population difference would be difficult to detect. That is, if the sample size were small, then even a fairly large difference in sample means might not be significant. If the difference is not significant, then no strong conclusions can be drawn about the population means, and thus the result would be inconclusive. You may prefer that your foundation's money be used to fund a project that has a higher probability of being able to make a strong conclusion. This question can be answered by considering the power of the proposed experiment. Power is defined as the probability of correctly rejecting a false null hypothesis. So, if the population means really are different, the power of the experiment is the probability that there will be a significant difference between the sample means. In terms of our math education example, let's assume there is a real difference between the methods. The power of the experiment would then be the probability that the sample means will be significantly different. The probability of failing to reject a false null hypothesis is often referred to as beta. Therefore, power can be defined as 1 minus beta. It is very important to consider power when designing an experiment. You should avoid spending a lot of time and/or money on an experiment that has little chance of finding a significant effect, even if the experimental hypothesis is correct.